The following diagram shows parts of the graphs of two functions f and g. The graph of f is linear. Question A, write down the equation for f in the form y is mx plus c. So f is a straight line and the equation is mx plus c, so we need to find gradient m and this parameter c. So to find gradient, we can see that there are 2 points on the hour line. It's point 0, 8 and 4, 0, and since we know 2 points on the line, we can just use the formula. It is given in a data booklet, and it's y2 minus y1 over x2 minus x1, and just substituting coordinates of 2 points, it becomes 0, 8. It doesn't matter what point is the first, what is the second. So 0, 8 and minus 4, 0. We get 8 over negative 4 is negative 2. Negative indicates that the line is decreasing, so we can see that it's true. Or just it can be found directly as a rise over run. You can see that if we consider these points again, you can see when x increases by 4, y decreases by 8. So it's negative 8 over plus 4, and you can get the same result, negative 2. So a gradient is found. So equation of the line becomes negative 2x plus c. To find c, we need any point to substitute for x, for y, and calculate and solve for c. C is directly y-intercept, because when x is 0, you can see that y is equal to c, and since we know y-intercept is 8, so we can conclude that c is equal to 8. In general, you may substitute absolutely any point which lies on the line for x, for y to calculate c in general, but here c is equal to y-intercept and it's 8. So y is negative 2x plus 8. The function g is given by g of x is negative x squared plus bx plus 8. Question B, find the value of b. So to find the unknown parameter, we need any point to substitute for x and for y to get an equation to be solved for this unknown b, and we need any point on the hour curve, and it can be negative to 0 or this one for 0. So let's substitute for 0 to get 0 is negative 4 squared plus b x, so so 4b plus 8, and we get that 4b is 16 minus 8, which is 8, so b is 2. The next shows that the area of the region enclosed by the graphs f and g can be represented by the definite integral given. Definitely we know that to find the area between two curves we use definite integral upper curve minus the lower curve and within limits, but we should show how to obtain it or how to get it here, and it is given in a data booklet that area between the curve and x-axis is equal to definite integral from a to b, and let it be some function u of x dx, but provided that curve is above x-axis, because if curve is below x-axis, you get an integral be negative, but by absolute value it will be equal to the area. So since two curves are above x-axis, we can say that the enclosed area is equal to area from 0 to 4 of between G and x-axis, this area, minus this area, and it is equal to the area enclosed by two graphs. So integral from 0 to 4 of G of x minus integral from 0 to 4 f of x dx, and it is equal to the required enclosed area. And since limits are the same, difference of two integrals is equal to one integral but of the difference, so it is equal to G, and G is what, negative x squared plus 2x plus 8 minus f is what, negative 2x plus 8, negative 2x plus 8 dx, and it becomes integral from 0 to 4 negative x squared plus 4x plus 8 minus 8 is 0 dx as required. In general, you can see this area can be found easily as just area of a triangle. It's just half times base times height. And the next question D, hence find the area of the region enclosed, so we need just calculate this integral. So it becomes, so integral from 0 to 4 negative x squared plus 4x dx is equal to integral of x to the power of n is equal to what, x to the power of n plus 1 over n plus 1 plus constant formula is given in a data booklet. So it becomes negative x cubed over 3 plus 4 and x to the power 1, so x squared over 2, so 2x squared, and limits 0, 4, and substitute in the upper limit we get negative 4 cubed over 3 plus 2 times 4 squared minus, and substitute in the lower limit, it's 0, it's just 0. And to be easier to calculate, we can factor out 4 squared, it's 16, to get 16 multiplied by this 2 minus 4 over 3, and 2 it's what, it's 6 over 3, 6 over 3 minus 4 over 3, it's what, 2 over 3, so it becomes 16 times 2 over 3 or 32 over 3. And the next point P is on the graph of G. The tangent to the graph of G at P is parallel to the graph of F. Question E, find the coordinates of P. So tangent as any straight line has equation mx plus c, but gradient of a tangent is equal to the derivative at a point where this tangent is drawn, and we need this tangent to be parallel to line with this f, line f, and gradient is negative 2. So if we know if two lines are parallel, they have the same gradients, so gradient of our tangent also should be negative 2. Hence we get that the derivative of G not F, because it's a tangent to the graph of G not F. It's just in general derivative of some function, but here function is G. So we get an equation derivative at some point is negative 2. So if we find derivative of G, and it's what? It's just negative 2x plus b negative 2x plus bb is 2, and this derivative is negative 2, and if you solve for this x, it's not arbitrary chosen x, it's x coordinate of point P, where this tangent should be drawn to have gradient to be negative 2. In general, you may write just x or x p, it doesn't matter. Let's write p. So it becomes negative 2xp is equal to negative 4. So x p is 2. So it's x coordinate of point P. And since this point lies on graph of G, its coordinates are connected by this function. So substituting for x, 2 for x, and g of x is equal to negative x squared plus 2x plus 8, and this point P lies on G. So substituting 2 for x into equation for G, it becomes y coordinate of P, so it becomes negative 2 squared plus 2 times 2 plus 8. It's negative 4 plus 4 is 0 plus 8 is 8. So point P has coordinates 2 and 8. And that's all for this question.